Hello everybody, this is Rudra Pradhan here. Welcome to Engineering Econometrics. Today we will continue with linear regression modeling, that to the issue of multiple regression modeling. So in the last lecture we have discussed about this particular component. So it is a issue where we have dependent variables and many independent variables, and the idea is to predict the dependent variable with at least two independent variables in the systems. So how we have to actually address these problems and how to analyze, we have briefly highlighted in the last lecture. And now what we can do, we can connect this particular technique with the a kind of engineering problem, and let us see how is the kind of outcome and how we can address these outcomes to predict the dependent variables particularly with respect to two independent variables. So now we have here a real estate data. Here the objective is to predict housing price subject to two independent variables, that is the square feet, the area of the house, and the age, years of kind of housing. So that means technically when a particular house is built and over the time, so there is a kind of depreciation. So as a result the house price may get actually affected. So actual housing price depends upon the how old is that particular building, and again how is the size of that particular house. So theoretical understanding is that if the square foot or size of the house is high or more, then by default housing price should high. If the square feet area is lower one, then the housing price can be lower one. And similarly when the house is actually old, then housing price will be lower, and when the particular house is a new one, then by default housing price can be high. So that means when it will over the years, when the number of years will start increasing, then there is a high chance that particular variable can affect the housing price negatively. So this is what actually the theoretical understanding before you apply the regression modeling, that to trivariate modeling or multiple regression modeling with the two independent variables case. So we can actually connect this problem and then check how these variables can be affected, or or means say to study the impact of these two variables to dependent variables. That means technically the issue is means how, what is the impact of square feet and age on housing price, and what are the ways we can actually investigate the particular process, and how to predict the housing price with respect to the square feet and age of the house. So compared to last problems which we have already connected in the case of part 1, where we have two variables, that is connected to airline industry, and where the objective is to predict airline cost with respect to airline passengers. Here the problem is different in the context of trivariate modeling, and that to multiple regression modeling with it two independent variables. So now in this case obviously the same sample point we cannot keep, we must have actually more sample point. In the first problems we have used 12 samples case, means sample size is 12, and here we are actually using a problems with 23 samplings. So that means this is what actually the problem. So these are all sample observations. So first 12 observations, and again remaining observation up to 23. So that means technically, so we have n equal to 23, that is the sample size, and then k equal to here's number of variables. So in the case of bivariate setup, k was 2. So now in the case of trivariate or multiple regression modeling with the two independent variables, then that becomes k equal to 3. So that means it is the simple kind of calculation is how many variables are in the systems, and by default how many parameters are in the systems including the intercept. And since in the case of bivariate case we have two variables, so by default k equal to 2. In the case of multiple regression with the two independent variables, so including dependent variables, so we have a 3 variables, as a result k equal to 3. So now for multiple regression modeling with the two independent variables, so the game is n equal to, means for this problem game is n equal to 23, k equal to 3, and as a result degree of freedoms n minus k, which is actually 20. So this will be 20. So so this is how the typical understanding. So before you start the process, as usual you can go through descriptive statistics and the correlation matrix. The correlation matrix by default will give you the indication about the x1 relationship with y, and the kind of nature of the relationship, and whether there is a link or not having link, then x2 on y, and then finally x1 and x2 for instance. So we can create a link like this, y x1 and x2, similarly y x1 and x2. So you can have a correlation matrix, and then you check what is the kind of relationship. So here y x1 and x1 x2. So ultimately y x1s you must have here, then y x2 you must have here, and y x2 you must have here. So this can be valid, this can be valid, this can be valid, and in between, so x1 and x2, so x1 and x2 this place, or x2 and x1 this place. So this is what the actually issue about the relationship between x1 and x2. So that means the problem will be like this, y with respect to x1 and with respect to x2. So x1 and x2, that correlation coefficient will give, and y x1 is here and y x2 is here. So obviously we need more correlation with the y x1s and y x2, but should not have any correlation or very low correlation between x1 and x2. This is what the theoretical overview and the descriptive statistic and correlation matrix can give, and you should actually check before you go for the estimation of the regression models with respect to dependent variable and two independent variables. So, right. So this is how the problem. So let us see how we can go for this particular problem and to solve the issue. So in that case, what I can do, I will take you to the softwares directly, then I will show you how these variables can be used in through these softwares to get these parameters. So means the first step of this processing to predict the housing price with respect to size of the house and the years of the house, we need to fix the model like this. So the technically the model can be fixed, it's like y equal to beta 0 plus beta 1 x1 plus beta 2 x2, and then error terms. So this is what actually housing price, and this is what actually size of the house, and this is actually years of the house. Okay, so this and this we expect positive relationship, and this we expect negative relationship, and then this and this we expect no relationship. So there should not be no relationship. This is how the theoretical kind of understanding and theoretical requirement before we start the processing, but the actual case is maybe something different, which we can actually get to know after using this data, connect with these models, and obtain the estimated model by using this software. So what will you do? Technically you can start doing actually descriptive statistics, then correlation matrix, and then after that we can get the regression output. So let us see. So first of all, with this is what actually the kind of data. So what I will do, I will just little bit enlarge. Okay, so this is what the 3 variable case. This is house price, and this is square feet size of the house, and this is the number of years of the house, how old this particular house over the time. So, as a result, so this is actually a completely cross sectional data. Different locations we have gathered the data, and that is what the kind of the requirement of regression modeling, and that to use the random sampling to collect randomly data from different locations and then predict the kind of scenario that will give you some kind of unbiased results. And if it is time series data, then in one particular locations, then you can over the time you have to collect the data. By default, if it is a particular location and particular house over the time, then what you will do with the same house and number of years old, then that will going on, then you will check how is the housing price is affected. Then that is the time series modeling structure, but in this case we are using cross sectional modeling to know the particular scenario. That means what should be the housing price if the number of years will increase or decrease, and the house size will be increase or decrease. So, that means technically what should housing price in the future kind of requirement, that is with respect to size of the house and years of the house. So, this is how the kind of case. So, now what will you do? So, you just go to the data analysis package and click here, and first of the requirement is the descriptive statistics, and put the descriptive statistic here, and you can go one by one. So, by keeping highlight this one, then you can get this is what the case of descriptive statistic. You just put summary statistic here. So, you will get summary statistic for x1, that is housing price. Again go to the data analysis, put the descriptive statistic, indicate second variables, and you will get second variable informations. Then again you go to the data analysis and again highlight descriptive statistic and give the indication about the third variable. So, you will get the descriptive statistic of third variables. In fact, you can indicate all the variables simultaneously, then you can get the descriptive statistic of the three variables one at a time. And after knowing this, so this is descriptive statistic of 1. So, you can see the kind of things. Just you have to check that mean, standard deviations, minimum, maximum, and then count the particular range. The range should not be 0, and range will be usually 0 when all the informations are same. That means there is no difference between maximum and minimum. So, before you start the processing of whether it's a bivariate structure or trivariate structure or any kind of multiple structure, so the variable in or data for a particular variable should not be uniform, and that too you can detect through the difference between minimum, maximum, and range and the standard deviations. In fact, if all the data points are same for a particular variable, then standard deviation will be 0 by default. So, if standard deviation will be 0 and minimum, maximum are same, range equal to 0, then by default this particular data set for that particular variable should not be used for the empirical processing. So, even that particular variable is very important, but if the data is not supporting, so you can simply drop the variable. If you do not drop the variable, then software will not give you any kind of result, because it is technically difficult technical defect case where same informations are there. If all the informations are same, it cannot give any kind of impact to the dependent variable. And if the dependent variables data set is the same, so there is no need to again predict the particular variables. So, you need to predict the dependent variables if there is a variation over the time or over the cross sectional unit. If there is no such variations, then you simply drop the idea to go for the kind of investigation, and that to predict the a dependent variable, in this case housing price, with respect to the independent variables. So, these are the basic things you must have understanding before you start the process and do the needful. So, that means technically what I like to submit that you must have clear cut information about all these variables, and that too with respect to data. So, theoretical understanding of these variables, and then the particular data set for these variables. So, theoretically these variables should be correctly identified, they have logical kind of linkage or theoretical kind of linkage, and the data availability for these variables should be also consistent as per the process of investigation. So, the investigation process requirement is that there should be some variations among these data points, whether it is a dependent variable or independent variables. If these variations are not there, then that particular variable, even it is important theoretically, logically, and as per the engineering problems requirement, still you should not use for any kind of regression modeling, and that to predict and forecasting the engineering problem or engineering requirement. So, as a result, so first submission is that whether it is a bivariate structure, trivariate structure or multiple structure, so you are supposed to report the descriptive statistic of all variables, because it will give you the clue about the starting to enter to the regression modeling. So, after knowing the descriptive statistic, again you go to the data analysis package. Now, you give the indication about the correlation. So, we need to know correlation, and that too for these variables, and we like to check that the relationship between y and x1 should be high, y x2 should be high, and no relationship between x1 and x2, and for that you just give the link here, and this is what the correlation matrix, and column 1 means it is y, and then column 2 is x1 and column 2 x3. For this problem, this is housing price, this is the size of the house, and this is the years of the house, that to how old that particular house. You will find a housing price and then the housing size. What theoretically we expect, there should be a positive association. Now, we in the correlation matrix we find the correlation coefficient is 0.77. So, that means, so it clearly indicates that if the size of the house is high, then housing price can be high. If the size of the house is low, housing price can, that means there is a positive association between housing price and the size of the house. Since the correlation coefficient is coming 0.77, and there is a high chance that that particular correlation or that particular link will be statistically significant. Of course, we have not given the option about this testing of this particular correlation, which is not required in the present context, because our aim is to predict the y with respect to x1 and x2. And then in the second items, where we are the correlation between housing price and the years of the house, and we expect theoretically there should be negative relationship, because when the house becomes old, then you cannot actually put high price. So, obviously, there is a negative relationship between the two, and the data is also supporting here. So, that means technically we find the kind of relationship between years of the house and the housing price are negatively related. That means technically the interpretation is that, so on the once the house is old, then the housing price will be low, and if it is actually a low new one, or years wise very low old, then you can put high price. So, that means technically, so here in the second case, so years of the house and housing price are negatively related. So, higher the old, lower the price, housing price, and lower the old, lower the housing, higher the housing price. So, that is how the negative relationship between housing price and age of the house. So, that means technically more old means low housing price, lower older means a number of that is the age of the house will have actually high housing price. And then finally, the third link. So, that is what actually between housing price and size of the house and the age of the house, which is actually coming minus 0.33. So, that means technically they are independent and their correlation should be 0, but unfortunately in this case the data is behaving like that, there is a correlation, and that correlation is coming minus 0.33. That means there is a negative relationship between these two, that is with respect to size of the house and the kind of age of the house, size of the house and age of the house. So, they are negatively related to each other, and there is a link. and that link may be statistically significant, and I think minus 0.33 means there is a high chance this will also statistically significant, but we can actually minimize. But again, since it is actually minus 0.32 and lesser to 0.5 means it indicates the log correlation coefficient, and you can go ahead with the prediction, but this may affect the particular process, and it may not be significantly affect the process because the link between x1 and x2, that is the size of the house and years of the house, is a very low correlation coefficient. So now the third case is the regression modeling, and for that again you go to the data analysis package. Now instead of correlation you come to the regressions. Then in the regressions, so our requirement is actually a dependent variable with independent variables. So what will we do? So first is the input y range. So y is here a housing price that starts with 2 unit to here 24 unit, because first one is the variable's name, and then again come to the input range. So it should have actually same range, otherwise a software will not help you to process your output. So now we have received the process, you just put OK. So this will give you, like previous case, in the case of airline costing. So here we get actually substantial regression output, and as usual, and we have discussed up to this much till now, and then this part. So that means technically our model is y equal to beta 0, beta 1, x1, beta 2, x2. So now here if I write like this, then it becomes y equal to 59.1 plus 0.017 x1 and plus minus 0. Okay, so this becomes then this becomes okay. So what you can do, you can directly put minus here, and then it becomes minus 0.771 x2. Okay, so the for x, that means technically x1 on y is the positive link and x2 y is on negative link, right? So which we have also obtained through the correlation matrix, where y x1 is the positive correlation and y x2 is the negative correlation. So that means the evidence from the correlation and the regressions are more or less same, and what is more important, correlation will not give you the impact and incidence case, cause and effect, but here we can obtain the cause and effect. So in that case, actually here x1 is positively influenced, but the influence of x1 on y is a little bit lower compared to x2, where the impact is negative, but it is the high one. So that means technically the interpretation is that when house the age of the house is actually decline drastically, then housing price will be affect very drastically. And in the context of x1, that is the size of the house. In fact, size of the house technically cannot actually increase for a particular house, but this model can be used for new construction or something like that. But the thing is that if the size of the house is the lower one, then housing price will be lower. Size of the house is the higher one, then housing price will be higher one. Okay, so this is how the coefficients. So this is for beta 0, and this is for beta 1, and this is for beta 2. So like this. So this is beta 0, this is beta 1, and this is for beta 2. And as a result, so we have beta 0 coefficient, beta 1 coefficient, beta 2 coefficient. So now this is what the estimated model. Now put x1 value and x2 value, then predict y. And before that, we should go for testing the reliability part of the model, like the part A, which we have already discussed in the case of airline costing, that to airline cost with airline passengers. So here also same things, the reliability part of the models will pass through all these tests, that specification test, then the goodness fit test, then the diagnostic test, and the out of sample prediction test. Since it is actually cross sectional modeling, so out of sample prediction test is not required. technically, and then diagnostic test, which we will discuss in the later part. But only important with this particular result is to check the specification test, that to check whether the parameters are statistically significant or not. So, that means technically we have three hypotheses here. First null is beta 0 equal to 0, then second null h1 0 you can put, then h2 0 where beta 1 equal to 0, then h3 0 where beta 2 equal to 0. Then accordingly you can apply t statistics and check whether beta 0 is actually 0 or not 0, and whether it is statistically significant or not significant. Similarly for beta 1 and similarly for beta 2, and for that you can apply t statistic, fix the probability level of significance at 1%, 5% or 10%. Since we are using software is actually directly giving the p values here. Then you compare with the critical value and the calculated value. The calculated value will be a beta coefficient, that is beta 0, beta 1, beta 2 with respect to their standard error, and standard error technically depends upon some of the squares of the error and divided by degree of freedom, which we have discussed in the part 1 case, and same case will be obtained here in the case of trivariate, that is the dependent variable with the two independent variables. So, ultimately for all these parameters for testing purpose, so we have a beta coefficients, that to beta 0, beta 1, beta 2. So, what we are supposed to do or to report before you start the testing. So, to find out the standard error of these parameters beta 0, beta 1, beta 2, and that is the square root of all these variance of these parameters. So, the standard errors for beta 0 is here 10.45, and standard error of beta 1 is 0.003, that is for x1 variables, and standard error for beta 2 is 0.24, that is for x2 variables. So, now beta coefficients beta 0 divided by standard error beta 0 and beta 1 by standard error beta 1 and beta 2 by standard error beta 2 will give you t statistic, which is having here. And if you go through probability check or decision making process, where we have to compare the critical value, these are all calculated value, and when we compare with the critical value, that to t tables with a particular probability level, let us say 1%, 5% and 10%, and the degree of freedom here n minus k, that to 23 minus 3, then you define critical value for 1%, 5% and 10%, then you compare with all these calculated value. The rule is very same, and that is very simple. So, if the critical value calculated value will overtake the critical value, then the particular parameter then the particular null hypothesis will be rejected, and justify that the particular parameter will be statistically significant. This is also for beta 1 and beta 2 and also for the intercept beta 0. And in this particular problems, all these parameters beta 0, beta 1, beta 2 are statistically significant, and this is what the specification test about, and that is clear and gives the green signal to go for the predictions of the housing price with respect to size of the house and the kind of age of the house. And the second part of the testing is goodness of fit test, that depends upon R square value, which is nothing but the ratio between explained sum of square by total sum of squares, and where we have here, and that is actually regression sum of square or explained sum of square, and this is actually unexplained sum of squares, that is error sum of square, and this is total sum of square. So, this by this with respect we will get R square, and then the next null hypothesis that x for 0, that R square not equal to 0, and for that you use F statistics, and F statistic is coming here 27.74, and that is also statistically significant. So, R square is reported here, and this is actually R square 0.74. So, 0.74 means 0.734. That is the case where the influence is 73% of independent variable impact on dependent variables. So, that means since R square is coming 0.73%, 0.73, that is the 73%. So, the impact of independent variable to dependent variable will influence out of 100 is 73. So that means if you change the independent variable, then the combined impact to the dependent variable will be 73. So 1 unit of change of x1 and x2 will affect the dependent variables in with respect to 73%. So that is the kind of interpretation you have to bring here. Then you can also check the individual impact of x1 and x2, because R square will give you the combined impact, and individual impact you can check through intercept estimate or variable estimations, that is actually through beta 1 and beta 2. And since R square is coming 0.73, which is close to high correlation, that means the prediction is good, and the impact of independent variable to dependent variable is also very high, and at the same time R square is coming statistically significant with the help of F statistics. So that means technically this estimated models, where our objective is to predict housing price with the size of the house and age of the house, is perfect one with respect to specification test and goodness of fit test. Of course, the diagnostic part is there, and it is left to again give the green signal before you start the prediction and forecasting. And this diagnostic test includes the relationship between also x1 and x2. So in the coming lectures we will discuss the diagnostic test issue, where it is not a kind of single one. There are multiple kind of tests are there in the diagnostic test baskets. So you will go through one by one and check the particular requirement, and then finally you give the green signal before you start the prediction and forecasting. And that means one of the issue which we have already highlighted is the relationship between independent variables, and that can be also part of the diagnostic test, because it is not located in the specification test and the kind of goodness of fit test, which we can discuss in the next class, and that too where we will connect with the all these diagnostic tests and including this particular issue, that is the relationship between x1 and x2. That is technically called as actually multi-congruency problem. And with this we will stop here, and we will continue this same lecture in the next class. Thank you very much. Have a nice day.